We are going to start off by looking at the QTR-1RC sensor. The board has 3 pins: VIN, output, and ground. VIN requires a constant 5 volts, and output will be enabled high with 5 volts with a digital pin. The sensor works using a photodiode and a phototransistor. The diode emits an infrared signal at the surface beneath itself, which reflects back into the transistor. When the infrared light strikes the transistor, it turns it on. With only a little bit of light, the switch doesn't allow quite as much current to flow when it is struck by a lot of light. Because a dark surface tends to absorb light much more than a light surface, we can use this effect to detect the brightness of the material. Now the chip has a small 10 nanofarad capacitor with one leg connected to 5 volts. When taking a measurement, the output pin is initially driven high, which puts 5 volts on both sides of the capacitor, effectively draining it of any potential difference. The output pin is then changed to an input while measuring its voltage. The phototransistor will allow current to flow, re-establishing a potential difference and driving the output pin back to 0. So, initially that 5 volt, which was based on the bottom of the side of the capacitor, is sensed by the output pin. However, as electrons flow to the bottom plate of the capacitor, the voltage on the output will fall, shown in the top wave. As the Arduino measures the output pin, it will actually continue reading a signal as high all the way to 3 volts. This means that the microcontroller will read a high signal from the time the pin is driven high to the time it falls below 3 volts, shown in the bottom wave. This time is what we measured to determine the type of material we are over, as a light or reflective surface will have a shorter interval than a dark one. So, let's go through some of this code. We're going to use pin 5 as our output pin. We're going to use pin 4 to deliver the 5 volts to the chip. We have a couple of variables we're going to use for times. This 1000 is what we're going to set as our reference time to decide if the object is white or black and if we should turn around. In the setup of the program, the first thing we need to do is set the baud rate for the serial monitor. So, for communication to exist between the Arduino and the computer, they need to both talk at the same speed. So this number needs to be the same in the program as what's set on the serial monitor. We need to drive the input pin high for VN, and we're going to print ourselves a message that says we're starting. So, in the loop, we're going to first set our output pin high. We're going to wait a second for that capacitor to charge, and then we're going to change to input and take the time of the Arduino in microseconds. We're going to continue to loop through reading for this pin until it goes low. When the pin goes low, we're going to take the time of the Arduino again in microseconds, and we'll subtract those two to decide how long it's been since the pin was high. Then we'll print this value out to the serial monitor. Now, if this value is less than a certain amount of time, then the chip fell fast enough for us to decide that it's over something white and we need to turn around. So, let's take a look at how to actually wire this thing. Got 3 pins: ground, VIN, and out. Ground's wired to Arduino ground. VIN is wired to pin 4. And output is wired to pin 5. So 4 is just going to be driven high to give us power. So, let's look at the Arduino code. We'll post it in the description. The first thing you're going to need to do is upload it. I'll give you a status bar when it's complete. So, we're going to go ahead and look at our serial monitor. So, it says hello. And you can see we're holding the sensor above the white paper, which would mean it's out of the ring. It's reading low values and telling us to turn back, recognizing that it's about to cross out. Now if we move back into the black, the color of the ring, we're getting very high values. It's taking a long time for that capacitor to drain.